yeah, I'll skip most of the introduction because you guys mostly already know me. I'm Wolf McNally, kind of lead researcher for Blockchain Commons. And obviously, I didn't invent Shamir secret sharing, and I didn't even invent the basic algorithm SSKR that's been done by some brilliant people. I'm not a cryptographer, but I am a software engineer for over 40 years with a lot of emphasis on usability and ergonomics of both UI as well as APIs. So that's one of the major contributions I'm really enjoying making with Blockchain Commons. So Seed Tool is basically kind of our flagship reference app that is a seed manager. Yeah, I'm curious if could you put a 1 in the chat if you have not played with Seed Tool yet, so I can just see how many people are totally unfamiliar with Seed Tool. If I see no ones appear, then I'll feel like, okay, everybody here has some experience with it. Okay, so Ken hasn't. So at least one of us has not. So that's okay. Yeah. So it's basically Seed Tool is kind of a showcase of a lot of the technologies that we've been developing, and so I definitely recommend it. And I'm going to switch over right now to my phone here, so you should be able to see my phone right now. The main page of Seed Tool is a list of the seeds you're managing, and in particular, so basically creating a seed is as simple as tapping the plus button at the top, and then you have a number of options, and all the documentation here, you can tap on an info button and it links to various kinds of documentation built into it. You can generate your own entropy through coin flips or die rolls or playing cards, so through diamonds, queen of spades,
Actually,
or just say
turns
all
out I
them.
lied.
Sorry, what?
Have it installed. I lied. I have it installed on my phone.
Great, yeah.
And I do remember it now.
Yep. Okay, good. So yeah, so once you've generated the seed, then it basically offers you the new seed. You can name it, add notes, and so on, and or save it. I'm going to cancel out of that. The main thing I want to demonstrate is how you back up a seed and restore it using SSKR. So I'm going to pick one of our standard kind of test seeds here, and I'm going to tap authenticate. I have two-factor authentication turned off on this build, so it's not going to ask for Face ID, but normally that's what it would do. And then I'm going to say tap back up here, and it asks me if I want to back up as a UR crypto seed or back up as an SSKR multi-share. So I'm going to tap that, and then this export page asks me which either preset or group or setup do I want to use. 1 of 1 basically means it's just like a way of backing it up, very straightforward, that you don't need this, but 2 or 3 is probably the minimum practical one, 2 or 3 shares. But if you want, you can get sophisticated as say 2 of 3 of 2 or 3 groups. So 4 shares from 2 different groups, 2 shares from one group, 2 shares from another group need to form a quorum to actually recover your thing. So you can also customize it here. So you see the group setup, number of groups, group threshold, and then the groups. You can set it up any way you like. Once I've decided what I want, I tap next. And then you have a number of options. It's generated the actual shares now. And it points out that because we use random numbers, if you leave this screen and come back, the shares it generates will be different. You can export the shares individually. And so here and we use 4 byte words to characterize each share. These are random, so they will be different if the shares are different. And if you want to have a UR, you can show it as UR. You can show it as byte words, which is our 4-letter way of encoding bytes. You can show it as a QR code. You can actually write it to an NFC tag if you want. So you just tap there. If your phone actually supports NFC reading and writing, that will be active, or you can print it individually. And printing, basically, this is what the preview of printing one looks like. Notice how the 4 characteristic words are at the end of the byte words. You also get the UR and a QR code on a single page. So this is what happens if you say export individually. If you say print all shares, then you can print them all at once, and you can preview the shares here. It prints a cover page that has the forward markers for every seed, and then it has 1 page for each of the various seeds. Or you can say multiple shares per page, in which case you get the cover page, and then you get like these coupons. And so if you want to cut apart the pages and distribute coupons, you can. each of which contains one of the QR codes. There's a couple other options there. So you can also export like all shares as byte words. You can save this to a file or copy to the clipboard, or all shares as crypto SSKR. So there's a number of ways of backing up your shares now that they've been generated. So I'm going to proceed because I've already done a printout. So let's assume I've printed out coupons, as I pointed out to you before. So now remember the basic SSKR that we're currently using currently doesn't save any of the metadata. So the actual name of the seed here, or if there were notes on the seed, those would not be saved because the capacity for SSKR is not very big. But the one we'll be showing you a little bit later with crypto envelope, you can have payloads of any size with the same basic mechanism that SSKR used, because instead of splitting the seed itself, we're splitting the symmetric key that's previously used to encrypt the payload, and that can be used for any size data. So if I want to recover the seed, all I have to do is go to the scan field here. And again, I'm using my camera here, and as you can see, I've got a printout here. That's the cover page. Now I could paste it from the file. I could load it from the file system. I could actually import it from photos, as you can see here, or I can read it from NFC text. So all those options are available. But I'm just going to pull this here. I'm going to show my first there. And now you see it's already started saying, okay, that it knows that there's 3 groups, that 2 of them are the quorum. It doesn't actually know, because of how SSKR is encoded, it doesn't know how many it needs in each group yet. So, but actually it says, though, it knows that I need 2 from group 1. And so I'm going to scan the second one here. And now it knows that group 1 is fulfilled. So it also knows that, for example, if I get one more from, it's got all 3 from group 1, even though it doesn't really need them. It only needs 2 from each, because this is a 2 of 3 of 2 of 3. So now it only needs one more from group 2. I'm going to skip ahead, though, and show it a couple from group 3. Oh, that was enough. And so notice it's characterized as dark purple. That's based on the life hash, which is another thing we have at Blockchain Commons. It's a visual hashing algorithm I designed based on Conway's Game of Life. And so the first word, dark purple, is based on its analysis of the color of the life hash. The remaining 2 words are just 2 new random byte words. So notice that even though the first one was dark purple aqua love, this is dark purple toys waxy, but you can tell from the life hash it's the same seed. It's just because the name isn't part of the SSKR payload at this point. So if I save that now, then you can see I've got dark purple toys waxy is the same as dark purple aqua love, and that's what the visual hash lets you do, is just identify that these are the same seed quite easily. So that's a basic demo of SSKR. Are there any questions on that right now before I move on to the next thing?
Just a quick one with the little fingerprint you have there. That's just the hash of the data, right?
Yeah, in this case, well, there's a specific way of generating the data that is hashed. It's ultimately a SHA-256 that's used as a seed for a 16 by 16 game of life.
No, I mean just the textual fingerprint, FFA.
Yeah, so that actually comes from the SHA as well. So this gives away nothing about the seed itself.
Right. So just curious, why isn't the name just derived from that? Why is it random?
Why is this different?
Yeah.
Oh, because you can rename it. You can basically give it another name down here.
Okay. I get that. I'm just like, why isn't the default just deterministic?
Oh, well, it's easier to remember. It's easier to identify, even if you never give it a name. Giving it a name that both is based on the color of the life hash as well as a couple random words gives it something that humans can hang on to better than a series of hex digits. So,
sorry, not my question. Let me rephrase. Why are the 2 words random as opposed to just being deterministic by the fingerprint, so they stay the same?
So
it's a completely off-topic question. I'm just curious.
Yeah, it's a fair question. I mean, basically, because even though the seed is exactly the same, I'm not assuming everyone will name the same seed the same on all devices. It's up to people, and so this basically makes it clear the name is not fixed to the seed. And so every time you import the seed, if I sent you the seed as a crypto seed, you get the exact same name, the exact same notes, and so on. But if I just hand you the seed, seed tool will generate the life hash, figure out a dominant color in it, give the first word or 2 will be the name of that dominant color, and then give it 2 random words, just to basically show this can be anything. It's not actually connected to the seed.
Yeah. Okay.
Makes
And
sense?
it is-
So it's kind of like user expectation thing.
Yeah.
Question, our kind of take on it, there's a trade-off between being able to import twice, where the data is slightly different. In one particular case, we're just getting the seed back, and the other, we might get notes and birthdays and other different types of things. This will become more important as we do crypto envelope as well, because you may end up having information that's available from one set of shards that is slightly different than other set of shards, and we don't want to lose the wrong set. So we'd rather have you have both and give you some dates. You can see a creation date here that allows you to go, oh, well, wait a second, that's an old archive.
Right. So yeah, and again, these are great conversations to have, and you can fire these kinds of questions at me anytime on Signal, and I'm happy to answer. About why we did things the way we did. Usually, there's a method to my madness, and Christopher and I had some long arguments about how to do things the best way. So yeah, obviously, this is something that we want these various pieces to be useful to the community. So if you want to use LifeHash, it's there. You are crypto seed, you are crypto SSKR, and as I'll be showing you, you are a crypto envelope. These are all things that are available, and we want to make them as widely used as possible, so people don't have to reinvent the wheel all the time.